India has always dreamed big when it comes to infrastructure. From ancient times to the modern era, the subcontinent has been a land of grand visions and ambitious projects. With over 1.4 billion people and cities growing faster than the roads and rails that connect them, the pressure is massive. The sheer scale of urbanization is staggering, and the existing infrastructure is struggling to keep up. Urban centers like Mumbai, Delhi, and Bengaluru are bursting at the seams, and the need to build under them, through rock, rivers, and everything in between, has never been more urgent. The challenge is not just about expansion, but also about sustainability and efficiency. To meet this challenge, the Indian government made a bold move. It decided to skip the slow process of building tunneling technology from scratch and instead bought 8 high-tech shield machines directly from China. This decision was both strategic and pragmatic. These aren't ordinary tools. They're towering giants of engineering, more than 90 meters long, weighing over 2,000 tons, and capable of carving tunnels through some of the harshest terrain on Earth. Their precision and power are unmatched. At first glance, it seemed like a clever shortcut. Why spend years on research and development when you can buy the best off the shelf? The move was seen as a way to fast-track progress and leapfrog into the future. This decision was more than just a transaction. It was a statement. It said India is ready to play with the big boys. It was a declaration of intent, a signal that India was ready to invest in cutting-edge technology and infrastructure. It was a leap of faith into the world of world-class infrastructure, signaling India's ambition to rival China, Japan, and Germany in engineering power. The vision was clear: to transform India's urban landscape and set new benchmarks in infrastructure development. There was genuine optimism. Engineers envisioned metro tunnels completed in record time. The potential for rapid urban transformation was immense, and the excitement was palpable. Politicians promised the public a new era of speed, safety, and progress. They spoke of a future where commuting would be faster, cities would be less congested, and economic growth would be spurred by improved infrastructure. Headlines buzzed with excitement. The deal was seen as a symbol of India's rise, proof that the country was ready to break free from old limitations and embrace high-tech solutions at scale. It was a moment of pride and a glimpse into a promising future. But as with any bold bet, the stakes were high. The project was ambitious, and the risks were equally monumental. And as the machines rolled into Indian ports, massive and gleaming, they symbolized hope and progress. Few realized that what came next wouldn't be a smooth ride, but a crash course in what happens when ambition moves faster than preparation. The challenges were about to unfold. When the massive Chinese shield machines finally arrived in India, they were treated like VIPs. The anticipation was palpable. Photos circulated of the colossal equipment being unloaded from ships, clean, shiny, and full of promise. It was a sight to behold. But once they hit the ground, the mood began to shift, quickly. The initial excitement gave way to the reality of the task ahead. Indian engineers and technicians gathered to begin assembling the machines, only to be met with a harsh reality. The complexity was overwhelming. The instruction manuals were mostly in Chinese, creating an immediate language barrier. The interface software was unfamiliar, adding another layer of difficulty. Critical components required ultra-precise calibration, and there was no margin for error. These weren't plug-and-play devices. Every step had to be perfect. They were like surgical instruments, the size of train cars, needing a level of coordination and expertise India just didn't have ready at hand. The pressure was immense. China had offered technical assistance, experienced operators and engineers who could guide the setup and initial tunneling. Their expertise was invaluable. But in a move driven by national pride and the spirit of self-reliance, India declined. The decision was bold and filled with patriotic fervor. The message was clear: we'll do this ourselves. It was a statement of confidence and determination. But doing it alone came at a cost. The road ahead was fraught with challenges, and the price of independence was steep. Months passed. Machines sat idle. Teams struggled with assembly, wiring, and integration. Errors during setup caused additional setbacks. In one case, misalignment during the installation phase led to damaged components that required replacement, further delaying already time-sensitive projects. And the pressure was mounting. Infrastructure delays in India aren't just inconvenient, they're political landmines. As deadlines slipped, public frustration grew. Headlines began to shift from optimism to criticism. Why are the tunnels still not ready? Where is the progress? Politicians started pointing fingers. Engineers defended themselves. Media outlets picked up the scent of failure, and the narrative started to turn. What had once been a bold step forward now looked like a stumble. India had taken a swing for the fences and missed the ball entirely. But this wasn't just about machines or project management. It was a deeper issue, a warning sign that would soon point to something more structural: the hidden cost of skipping the learning curve. The real problem wasn't just mechanical. It was foundational. It went beyond the surface-level issues of machinery and technology. India had purchased some of the most advanced tunneling machines in the world, investing heavily in cutting-edge technology. But what it didn't buy, and couldn't import, was the decades of deep, hands-on experience required to make them work. The expertise needed to operate and maintain these machines was missing. To understand the gap, you have to look at where these machines came from. The origins of these technologies hold the key to understanding the challenges faced. China didn't always lead in tunnel boring technology. Their journey to the top was a long and arduous one. In the 1990s, China was facing its own infrastructure crisis, struggling with poor roads, clogged cities, and risky manual tunneling methods. The situation was dire and demanded innovative solutions, so they did something smart. They started importing shield machines from Germany and Japan. These machines were the best in the world at the time, but they didn't just use them. They studied them, disassembled them, rebuilt them. They took the time to understand every component and function. Slowly, China developed its own models, tailored to its terrain and climate. They innovated and adapted the technology to suit their specific needs. By 2008, it had built its first domestic shield machine. This was a monumental achievement, marking a new era in Chinese engineering. Today, China builds hundreds a year and uses them across the country for everything from high-speed rail tunnels to urban metros. Their infrastructure projects are a testament to their progress. That rise wasn't an accident. It was the result of strategic planning and relentless effort. It was the result of long-term investments in civil engineering, industrial training, and advanced manufacturing. They built a robust ecosystem to support their ambitions. Chinese universities built tunneling departments. They focused on education and research to drive innovation. Factories created dedicated teams for precision assembly. Every aspect of the process was meticulously planned and executed. It wasn't just about owning the tools, it was about mastering them. The knowledge and skills were as important as the machines themselves. Now contrast that with India. The approach was fundamentally different. Instead of walking the same path, learning from the ground up, building institutional expertise, and growing a trained workforce, India tried to leap directly to the finish line. They aimed for quick results without laying the groundwork. It's like handing someone a spaceship when they've only ever flown a glider. The gap in experience and knowledge was too vast. You might have the vehicle, but not the flight training, mission control, or systems knowledge to get it off the ground. The infrastructure to support such advanced technology was missing. This wasn't arrogance. It was a miscalculation. The complexities were underestimated. The belief that machines could solve problems on their own overlooked a hard truth. World-class technology only works when you have a world-class ecosystem behind it. India had the ambition. They had the vision. China had the preparation. They had the experience and the infrastructure. And that difference, invisible at first, soon became impossible to ignore. The results spoke for themselves, highlighting the importance of a solid foundation.